All right, so today we're going to be talking about energy pyramids and also how energy flows throughout an ecosystem. So the essential question we're going to be asking is, how is the flow of energy through an energy pyramid diagrammed? All right, so first we're going to talk about how energy flows and then how it can be shown using what we call an energy pyramid. So energy in a living system. All living things need energy. Energy made by plants through photosynthesis is transferred to an animal that eats it. All right, so we've been familiar with photosynthesis. We've also talked about cellular respiration. Now we're going to kind of all bring this full circle and show how energy from plants and animals is transferred to other plants and animals. The organism then transfers that energy to the next organism, which eats it, and so on and so on. And then the graphic that we use to represent this, like I said before, is called an energy pyramid. So, how is an energy pyramid organized? Well, it's organized into what we call trophic levels, the feeding position in a food chain or energy pyramid that an organism occupies based on what it eats. So here we have different trophic levels. Trophic level 1 is here at the bottom, trophic level 2, and then trophic level 3. Notice that here at the bottom, this is larger, gets a little bit smaller, and then smaller here at the top. Okay? So energy decreases from lower to higher trophic levels. So there's more energy available here. This is where plants are, and we'll talk a little bit about plants and how they're producers. And then at the next level, there's a little bit less energy available, and then less energy available at the top. And then biomass is the term for living or organic matter, and this decreases from lower to higher trophic levels. So the population of hawks is going to be much lower than the population of a maybe certain type of plant or squirrels. So what makes up an energy pyramid? Well, here at the very bottom, at the base of the pyramid, we have producers. Producers get their energy from the sun. They make their own food through the process of photosynthesis. All right, they take in carbon dioxide, sunlight, water, produce glucose and oxygen. And we call these autotrophs, which basically means that they make their own food. All right, so here we have producers. Then the remaining levels of the energy pyramid are made up of consumers. Consumers are unable to make their own food. They're heterotrophs. Basically, that term just means that they can't make their own food, so they have to eat other things like plants and animals. Now, each of these different levels of energy pyramid, they're all consumers, but they're all different types of consumers. So first we have primary consumers, which are right above the producers. They're the first to consume, all right, because remember, producers don't consume. They get their energy from the sun. They're herbivores, so they cannot make their own food, and they only consume plants. All right, so here we've got some insects, we've got a mouse. They're heterotrophs, remember, because they cannot make their own food. Then we have secondary and tertiary consumers that make up the second and third level of the energy pyramid. They eat the primary consumers and each other. They're carnivores, so they only eat other animals. They do not eat producers. They're heterotrophs, because remember, that term means that they cannot make their own food. And then at the very top, we have our quaternary consumers. These are our apex predators. All right, so they're at the very top of the food chain, the food pyramid. They don't really have to worry about any predators consuming them. So like I said, they're at the top of the food chain. Nothing else preys on them. They are carnivores. All right, so they'll eat the snakes and the tertiary consumers, or the mice and the frogs and the birds in the secondary consumers. They are also heterotrophs because they do not make their own food. And then let's talk a little bit about decomposers. All right, because decomposers, they consume or eat dead plants and animals. So they're like the garbage men of the ecosystems. So they're active at each level of the pyramid, and they break down dead organisms and return nutrients back into the environment. So any of the different levels of the pyramid, if one of those organisms dies, they decompose, get broken down by decomposers, and then that nutrients is added back into the environment, which can be used by producers. Notice the shape of the energy pyramid. Okay, it is a pyramid. So the energy pyramid shape shows how the amount of useful energy that enters each level, so the chemical energy in the form of food, decreases as it is used by the organisms in that level. Notice there's more energy available to producers, less energy available at the very top where you have the lion. So how does energy flow through an energy pyramid? The amount of energy in every level decreases by about 10% as you go up. So what happens is you have 100% of the available energy here at the producers. Well, what happens is only 10% of that energy is available for the first level consumers. And then 10% of that is available for second level consumers. And then 10% of 1% is available for third level consumers. So there's less energy available for organisms located near the top of the pyramid, which is why the population of those organisms, those animals, is much lower than the population of first level consumers or producers. Now we measure the energy that is transferred in kilocalories or joules. 1 kilocalorie equals 4,184 joules. So if we were to look at this energy pyramid here, what we would do is we would take, okay, so here's our producers, and then we would look, okay, well, how much energy is going to be passed on to the next level? Well, you would take 10% of 1,000. 10% of 1,000 would be 100 joules, and then you go from 100 joules to 10 joules and then to 1 joule. Notice that only 10% of the energy is passed on from one level to the next. So go ahead and pause your video, and I want you to try to see if you can find out, if we start with 5,500 joules, what would we end with as we got all the way up to the top? So where does all this energy go? If only 10% is passed on, what happens to the rest? Well, we talked about the law of conservation of energy and how energy is not created or destroyed, so it has to go somewhere. So the energy is used up by the animals' metabolic processes during running, eating, finding mates, escaping danger, and daily living. And then it's given off to the environment as heat. So that's what these arrows represent here. That's heat being given off by those organisms within each of the different levels. The consumers at the top of the food pyramid have much less energy available to support them than those closer to the bottom, so that's why their numbers are relatively fewer. You're going to have fewer hawks up here in the top third level consumer than you would mice in the first level consumer, because there's not enough energy to support a large population of those organisms. All right, that concludes our slides for the day. If you have any questions, please feel free to email me. Thank you.